So this is section 12.2, and it's talking about just looking at different real world situations. So here's example 5 on page 831. So this is just modeling donations for the Ice Bucket Challenge. So by August 12, 2014, there was a cumulative $4 million in donations for the Ice Bucket Challenge. Okay, and this number was increasing 21.8% per day in August. So they want to know what the daily growth factor after August 12th. And then write an exponential equation and then evaluate it at 16. So if you look at A, we took the R, which was the percent, which 21.8, changed it into decimal. Then we added it to 1 because that's our formula. We get 1.218. Okay, then we write the equation. We know that C is 4 because we're looking at $4 million. We're not going to put millions in there, just put 4 in. We know we're talking about millions. And then A, we calculated from step part 1. And then we write our equation. We start with 4, and then we have our growth to the x power. Now we put in 16, and so we take this number to the 16th power, then multiply by 4, and we get 93.8. So in the 16 days following August 12th, the donation grew from 4 million to 93.8 million. Whew, wow. So let's try another problem. Let's go to page to the back and go to problem 93. And that problem is on page 837. So let's go to the 837. And we're looking at 90, what I think we were doing, number 93. Okay, so 93. So let's go down to 93. So here it is, a blood alcohol. Suppose that a person's peak blood alcohol level is 0.07, and that's in grams per 100 milliliters, and that this level decreases by 40% each hour. So what is the hourly decay factor? Write an equation, exponential equation function, and then evaluate it when you put 2 in, and then interpret what that means. So let's go to our drawing board. Okay. So let's write down all the important information for problem 93. Okay, so I have 0.07. Okay, and that's in grams per milliliter, 100 milliliters. Okay, and then it said it decreased at 40% each hour. Okay, so A, I'm going to find the decay factor. Okay, so the decay factor would be 1 minus the 0.4, so that's going to give me 0.6. So there's my decay factor. And then for B, it's B of x equal to the CA to the x. So that would make it let's see, I have to do 0.07 times 0.6 to the x of b of x. So there's my equation. And then for C, I'm supposed to do b of 2. And so it's 0.07 times 0.6 to the 2. And so I end up with, I've done this calculate already, it's 0.0252. And that's after 2 hours. So basically it's 0.0252 grams per 100 milliliters after 2 hours. And so these are the kinds of problems that you will be facing. So just wanted to do another problem for your notes.